Hello, welcome to the second question that we'll go through today regarding the volume and surface area. So for question 2 here, we're going to cover the pyramid that I talk about that the formula list you typically will not be seeing it much because of the fact that it is made of simple shapes like rectangles and triangles or even squares, which is probably why they don't provide that in the formula list. Tell me if I'm wrong, correct me. So in this question here, we have a souvenir from Sentosa, and it's in the shape of the pyramid. So they give you some measurements, including the length, the breadth, and the height, BO, right? And they start off by asking us to find the total surface area. Now, if you have caught up with our question 1 of the volume and surface area, you would have remembered that what we normally start off with is to create a general formula based on the outcome that we want to get to. So we know that to find the surface area of this entire pyramid, you have to look at the area of the different faces, basically combined all together, right? And it's made up of the area of the rectangle, which is the breadth, or rather length times breadth. So there is a length times breadth we have to find. All right, this number we have, right? And we also need to find the area of the 4 triangles that are around the side. So take note that for a rectangular pyramid, the triangles on the left and right are identical, meaning for the left hand side, if you notice the base that you are using is the same as the base on the right side, right? So that will be area of triangle is half times base times the height. Now, there's a lot of misconception in regards to the height of the triangle for a pyramid. A lot of students might think that the height is still referring to the 8 cm. So it is not, because it is not perpendicular to this base that is on the side here. And what is the real height is actually the slant height on the side here. It is in between, in the exact middle of the triangle here, a line that is 90 degrees from the base to the highest point, and that is known as a slant height. So I'm going to call it slant height number 1, and typically for slant height we use the letter L to represent it. Okay, so you know that the left and right are the same, so I'm going to times 2 to that. Will basically settle the left hand side triangle and the right hand side triangle together. Now the next thing that is not found also is the front and back triangle. So once again, the front and back triangles are identical to each other, but it's not identical to the left and right. Okay, reason being because you notice that the base this time around for the front triangle uses the length of 9 cm. So in other words, it's half times the length of 9 cm multiplied by a slant height that is also different from the slant height of the left and right triangle, because this slant height here comes from in the middle between the A and B, right? That creates a 90 degree against the ground. And this number is definitely not the same as the slant height on the side. Do not assume they are the same, okay? So I'm going to call this slant height number 2. And once again, because the front and the back triangles are identical, I am going to put a 2 times on that, and that will settle both triangles one shot, right? So put in all, I will need to use half length times breadth, that is the first surface area, to add to 2 times of half times b times L1, that is to find the area on the left and right triangle, and also another 2 times of half times base times height, which is the L, which is the length times the slant height, number 2, right? To find the last 2 areas and add them all together, that will be the surface area. But then again, why do we write the general formula is to make sure that we have all of these ingredients before we substitute the number in, right? So definitely length and breadth we have. We know that it is the 9 and 7 on the floor, right? And if you look at the triangle on the left and right, right? For the left hand side triangle, we know that the breadth, the base is using the 7 cm, the breadth of the rectangle. So that one we have, but we do not have the slant height of the first one on the side, right? We neither have the slant height of the one in front as well. So those are the 2 unknowns that we have to find first before we can get the surface area. All right, and to get the slant height on the side, you have to look at a right angled triangle involving the 8 in the middle. Let me erase some other highlight portions so it might be clearer. And the horizontal length here that basically connects from the midpoint O to the middle of A and D, right? And then finally the slant height here. Now this triangle here that we just created is a right angled triangle, which means that to find the slant height, we need to use Pythagoras Theorem. All right. So for the 9 cm that covers from the left to the right, if you want to get the left hand side, then you just need to use the 9 to divide by 2 because you're only getting the half of the horizontal length across, right? The whole length covered across is 9 cm. So you get half of it, which is half times 9. So I'm going to just use 9 divided by 2 to get a 4.5 cm. So the labeling wise, if you want to label, you can create one more point here. Maybe call it M or something and call it OM, right? But if you do not want to, it's fine. You can leave it just like that. And then we're going to find the slant height one. Take note of the labeling in mathematics. Sometimes if you throw in unknown symbols, some schools might be very particular about like what does that symbol stand for. So you got to probably label like let L1 be the slant height, you know, on the left, that kind of thing. So if you want to avoid that, you can use, you know, like an actual spelling of what you are trying to find, which is the hypotenuse side of the right angle triangle, which means you use 8 square plus the 4.5 square root it. When you want to find the hypotenuse side, you always need to find the sum of the base square and then the height square, right? It has to be the sum, right? So I'm not sure how confident are you with the shortcut. Just take note, it will be a square of the base plus the square of the height, and you square root that because you have to add them when you want to find the slant height, which is the longer side of the right angle triangle. It has to be a sum. Okay. So in this question here, I think this is not a perfect square, which means if I were to type out everything in the calculator, it's probably going to give me a weird number, right? So since this is not a final answer yet, I'm going to leave it in a square root form, which means I just ignore the square root, put it outside, and I only type in 8 square plus 4.5 square in my calculator. After all, you do not want to round off too many things as it's not a final answer yet. If you straight away round off to 3SF, it's going to cause accuracy problem when you get to the final answer. Yeah. The next thing I'm going to do is to look for the second slant height that we don't have. So this triangle being formed this time around involve the same 8 cm. Notice that for all slant height, you will use the common 8 cm, right? And it will also involve this line here that is connected from the midpoint O to the front in the middle between A and B, right? This point here. And then lastly, the slant height that we want to find is the hypotenuse side of this right angle triangle. So long that it involves a side on the base, and as long as the other side is a vertical side, right, like Ultraman like that, it is always going to be 90 degrees to each other, right? One side that is on the base, another side that is vertical. These two will always form a 90 degree. Yeah. So to get a slant height number 2, again, this is the hypotenuse side. So when you do the shortcut in terms of Pythagoras theorem, take note that some of the schools, if they are stricter schools, they might expect you to write, like when you use this method, what kind of theorem are you using? So you might want to say by or using Pythagoras theorem. We always want to practice the best habits, right? So long that, so to make sure that everything we write is the usual standard acceptable in the exam marking style, right? Marking scheme. So I would say that even if you don't write this, most schools will accept. So it's just certain schools that will ensure that you want this to be written down whenever you use a Pythagoras theorem. Yeah, take note of what your school expects you to do. So it's going to be 8 square plus half of the. It's no longer half of 9. Yeah? So right now, if you look at this length here, this number here is actually half of the breadth, right? It is the distance that is going from front to back, you cannot look at the 9. So it should be half of the 7. And if you haven't worked it out earlier, like what we have missed out earlier, we can just put it as 7 over 2 squared. All right, and once again, I don't think the answer inside is a perfect square. So I'm going to leave it in the square root form. All right, which is going to be 76.25 square root. All right. And the next thing I want to do is I would be able to put in all the numbers into the formula because I think all of the elements are there, right? We have length and breadth, we have the base of the triangle, the height of the triangle, which is the different slant heights that we have. So we will sub it in to find the total surface area. Now, personally, I do not like to create too many number statements regards to this kind of question because if you do that, it's going to cause what are the chances? Like, for example, you might type the wrong number in the calculator. You might round off wrongly in the immediate steps, right? When you transfer the number, you might transfer wrongly. And you can have a higher chance of making careless mistake if you split this up into several steps. Your school will accept it nicely so long that you write the formula properly. So you can label like immediately we are trying to find the total surface area. That will be the base area of the rectangle at the bottom, right? That will be 9 times 7, length times breadth, plus again 2 times of the area of triangle on the left and right, which is 2 times half times 7 times the slant height number 1, which is this number here, 84.25. And then I still have to add in the 2 triangles on the front and back, which is again 2 times of half times the length in front, 9, times the slant height number 2, which is 76.25. Okay. Then I will work it out all using the calculator. Now I noticed that some students know that because when you use 2 times half, it actually becomes 1, right? So some of the students might not be putting this in, but if you ignore this, and then you should already put something like 7 times square root of 84.25. I am not sure if your school will accept this as method mark because it doesn't follow the idea of having 2 times of area of triangle, right? You're just basically combining them into like a rectangle, and I am not very sure if the school will accept that. All right, so we always want to be as clear as possible with our steps. So even though 2 times half is just 1, some students might say, "Hey, teacher, isn't that redundant?" Yeah, but you still have to put it down to follow the best practice, right? All right, so if you work out them all together in the calculator, you should get 205.840558. I will write to maybe 4 or 5 decimal place before I round off my answer to 3SF. So that later on, if let's say the question requires us to use the part A answer to continue, we will not be using the 3SF answer because it's not that accurate, right? Let me record it down here because I might need to erase my steps for small space. Okay. All right. I'm also going to record down some of this slant height that I've obtained just now so that I will not forget a number, because I'm going to erase my steps now for part 2 and 3. Okay, part 2 wants us to find the volume of the souvenir, which is we will apply the formula for pyramids. Now, take note that for the pyramid and the cone, they are all very similar. It all involve 1/3, right? In my previous sharing that I shared with you, I mentioned that as long as you see a kind of a 3D figure that converge to one point at the vertex at the top, this volume formula will always involve 1/3, right? The two shapes that has this kind of pattern that converge to one vertex at the top is basically a cone and a pyramid. So it's going to be 1/3 times the base area of the pyramid, which is the length times breadth, times the height. Okay, 1/3 times base area times height. So again, the reason why it involves 1/3 is because if you compare this pyramid, right, to another cuboid that has the same base, same rectangle base, and the same height of 8 cm, basically when you compare that to this, what happens is that you are actually chipping off away 2/3, so that when you cut off all the sides to converge into one point at the top, 2/3 of the volume has been chopped out. Yeah, that is the idea. Or another way to say it is if you try and fill up the pyramid, right, completely with water, you will need 3 of this pyramid to fill up the cuboid of the same base and the same height completely. Yeah. All right, so that was 1/3 times 9 times 7 times the height, which is 8, and all of these numbers are already there. This will be a fast one for part B, right? Which is 9 times 7 times 8 divided by 3, 168 cm cubed. This is the exact answer that we still need to round off. All right, and part C, then they want us to link this to the material being used. They say that this is a steel pyramid, and the condition for this product to work is that it must not have a mass greater than 1325 grams. Now, it's a pretty heavy pyramid because of they use a steel for that. All right, and then they say there are 4 types of steels that is available, and these are their densities. So the density for carbon alloy stainless and 2. So you can see that there's some lighter ones and some heavier ones. Okay, so what density basically means is how much mass is condensed in the same amount of space available. So that means when you compare all of these 4 different types of metal based on a volume of 1 cubic centimeters, how much mass is stored in there, right? So the greater the density means that for the same amount of volume, it actually is heavier. Just like when you try and carry a brick, as you compare to carry a kind of styrofoam, right? For the same amount of space you occupy, the brick is much heavier as compared to the styrofoam, isn't it? Yeah. So they want us to find out which type of steel could be used to make a souvenir. And for this kind of question, when students see the amount of information the question provides, most of them will have this mindset of blanking out or maybe want to give up. But if you think about it, right, most of these questions are designed in a way that is still related to a syllabus, and particularly when they relate to real life application, they are actually not that hard, really. Like it's all just basic. Most commonly, they are usually basic mathematics skills that you can even apply if you don't have the knowledge from that comes from the secondary school level, which means that even in primary school level, you would have already learned them before. Some of them, yeah, typically. Okay, so to solve this question, since the density is related to the volume, and you must connect that to the mass to find out which ones are going to be less than or equals to 1325 grams. It cannot exceed that. That's the criteria. So we're going to find out which ones will be acceptable, right? And since it's related to volume, we're going to use the part B answer to continue. So basically, it's just to find the mass of carbon if you use the carbon material. And you know that the density means for every 1 cubic centimeters, that mass is going to be 7.87 grams. So if you got this amount of volume, that will be 7.87 multiply, because it's like you want to get from 1 to 168. 168 is like trying to get 168 times of that, right? So 7.87 times 168 is going to give you the mass for the carbon. All right, so this one is slightly less than the criteria that what be acceptable for the pyramid. So you can use carbon, right? And second one, let's try it for alloy also. Definitely, alloy density is less than carbon. So even if you don't do out the working, you would know that it's going to be acceptable as well. But because typically this kind of question, they are looking for the presentation steps that involve to give you the method mark. So you can't avoid that. Yeah. All right, and let's do the last two as well for the stainless steel as well as the tool steel. They are all simply multiplying. You get the idea. You can see the steps are just basically made of one step for each of this mass, just to find out whether they are within the limits. All right, so based on the answers that are out, you can see that the 1344 grams and the 1411.2 grams are over the limits of what they are accepting for the souvenir. So we are going to choose the first two as our answer, meaning we will choose the carbon steel as well as the alloy steel. That is going to be the two different types that are acceptable, right? And of course, when you want to buy something, they will also take the weight into account, right? You want to carry it back to such a heavy souvenir as well. Right, that's all for today. Charles.